Okay, so this is higher paper question 6. So nitrogen is a non-metal found in group 5 of the periodic table. Airbags are used to protect the passengers in a car during an accident. When the crash sensor detects an impact, a mixture of chemicals reacts chemically to produce nitrogen gas. The nitrogen fills the airbag. So this is a diagram here of a steering wheel, a cross section through the steering wheel. So that's the steering wheel there. This is the hub of the steering wheel, the middle of the steering wheel. This is where it's attached to the car itself. And here's the crash sensor. And then in the middle of the hub of the steering wheel, there is this mixture of chemicals. When there's an impact, a reaction happens here that produces lots of nitrogen gas very quickly that fills up the airbag. Okay, so the mixture of chemicals contains sodium azide, or NaN3, which decomposes on heating to form sodium and nitrogen. So decomposes in this instance means it simply falls apart to produce the two elements it's made from. The symbol equation for the reaction is as follows. So it tells us here that 2 moles of sodium azide react to form 2 moles of sodium and 3 moles of nitrogen gas. Okay, and it's this that inflates the airbag. So calculate the theoretical maximum mass of nitrogen that will be produced when 17.6 grams of sodium azide decomposes. Okay, so if we use our triangle, okay, that's the way we're looking at it. And we have mass, moles, and MR. Okay, so for the sodium azide, we want to know how many moles of sodium azide there are in 17.6 grams. Okay, because then we can use information from the equation to calculate the number of moles of nitrogen. Okay, so the number of moles is the mass divided by the MR. We're given the mass, okay, so 17.6 grams. And the MR we can work out using information given to us in the question. Okay, so the MR of, so we'll do this over here to one side, MR of NaN3 is 23 plus 3 times 14. Okay, so the 23 is the mass of 1 sodium, and 3 times 14 is the mass of 3 nitrogens. So to ensure we get this spot on, we shall use the calculator. So let's get rid of the previous answer. So 23 plus 3 times 14, 65. Okay, so 17.6 divided by 65 will give us the number of moles. Okay, that's 65 grams per mole. So let's put that into the calculator. So 17 point, let's cancel everything, cancel. 17.6 divided by 65, okay, is 0.27 moles. Okay, now if we have a look at the equation now, we see that for every 2 moles of sodium azide, we get 3 moles of nitrogen. So it's 1.5 times more moles. Okay, so that 0.27 we need to times by 1.5, because 3 is 1.5 times bigger than 2. Okay, so if you multiply 0.27 times 1.5, it gives us 0.4. Okay, so that's 0.4 moles. And then we need to multiply that by the MR of nitrogen to get the mass, because the other end we need mass is MR times moles. So we know the moles, that's the moles. The MR we can gain from the question. And so the MR is 2 times 14. because nitrogen is 14 and there's 2 of them. We're only interested in the MR of the formula, not of the whole thing. Okay, so 2 times 14 is 28. So 28 grams per mole. And so if we multiply that by 28, gives us 11.34 grams of nitrogen. Okay, so what this is telling us is if you have 17.6 grams of sodium azide in your steering wheel, when it turns into sodium and nitrogen, then it produces 11.34 grams of nitrogen. Okay, which adds up because it's less than 17.6, and the sodium is relatively heavy. Okay, so once we've done that, we discover that during the testing phase of sodium azide airbags, the actual mass of nitrogen gas produced was 10 grams. So we're expecting 11.34. We only get 10 grams. So calculate the percentage yield, give your answer to 2 significant figures. So percentage yield, we need to take the actual mass, which is this value here, and divide it by the theoretical mass. That's how much we should get. And then we multiply that by 100 because it's a percentage yield. Okay, so if we do that on the calculator, so 10 divided by 11.34 times 100. And the question, it asks us for 2 significant figures. So basically it's the percentage without any decimal place, and that would round down anyway, so that's 88%. So we've got 88% percentage yield of nitrogen. Okay.